Yep, that's a good answer, Ryan. Yeah, the main ones we talked about last week were your MCB or your miniature circuit breaker. Yep, yeah, which protects against overcurrent and short circuits by tripping the circuit. You got your RCCB or residual current circuit breaker. We commonly just call them RCDs. But the RCD is a broad term for multiple types of different RCDs. So they detect leakage currents to prevent electric shocks, and then your HRCs or your high rupturing capacity fuses, they provide high braking capacity for industrial and high current applications. So just remember, guys, I know obviously some of you don't have cameras, some of you can't turn on your cameras for various reasons. But so the more you guys interact in the chat, even if I start answering a question that I've asked, just keep responding. That way, the more responses you have in the chat, the easier it is for if anyone questions, or how do you know they were there if they didn't have their camera on? Well, they said this many things in the chat, so I know they were there. Cool. So moving on. So true or false? A residual current device or RCD provides both overcurrent and earth fault protection. Oh, so yeah, false unless it's an RCVO, and RCD only provides protection against earth fault or leakage currents, not overcurrent. So yeah, if it's combined with the circuit breaker and an RCVO, it does provide overload protection. So what's the main difference between a fuse and an MCB? Yeah, so majority of you, yep, are on the right track. So yeah, so fuse is a single use. The fuse element melts and needs replacement after a fault. Uh, an MCB can be reset manually after tripping, offering reusable protection. Where might we want to use, other than the high rupturing capacity ones, where might a fuse be advantageous versus a circuit breaker? Actually, don't. So one instance I can think of is a situation where you don't want the user to be able to reset the circuit breaker. So if a fuse blows in, say, a motor control, then the user can't just be like, oh, it tripped again, reset it. The fuse will break, and then so someone has to physically come out and have a look. So sometimes a one-time use is a good thing. That means someone can't just flick it back on. Cool. Which safety feature of an HRC fuse prevents explosion during high fault currents? Yeah. So you guys are on the right track. So yeah, so the answer is arc quenching. So the fuse contains materials like quartz sand to absorb and extinguish the arc safely. And the quartz sand mixes with the vaporized silver nitrate. I can't remember off the top of my head. Um, and mixes with the sand, which quenches the uh, arc immediately. Cool. So, what are two safety considerations when installing circuit protection devices? What do you need to think about when you're selecting a circuit protection device to install? So yeah, most of you got the first one. So you got to ensure the device is rated correctly for the circuit's current load as well as the potential fault current. And then you've got to verify proper installation to avoid poor connections and potential hazards. Um, Probably not many of you have been told this, but you're actually supposed to set your circuit breakers with a torque screwdriver, and they should be torqued every 3 to 6 months. Because what happens is as load passes through your copper cables, it expands, contracts, expands, and contracts, and so it will shrink inside the terminal, and so they need to be tightened at least once every 6 months. Some people have contracts to do this when they install big switchboards, and it's just good practice. Yes, you can just tighten the ever living crap out of them, but that only does so much. But each circuit breaker, if you look on the side of them, will have a torque rating in Newton meters that you're supposed to tighten them to. When inspectors install meters, they torque the screws inside the revenue meter as well. Cool. So describe the function of a surge protection device or an SPD. All good, Connor. We're just doing some revision uh, from last week, talking about SPDs or surge protectors. So for a surge protector, so SPDs protect electrical circuits and equipment from voltage spikes by diverting excess voltage to the ground, preventing damage from lightning strikes or electrical disturbances. So they contain voltage dependent resistors. So once they reach a certain voltage, they decrease in resistance. And so the over voltage and over current see that as quickest path to Earth. So they go through that instead of going through the rest of the installation. Yeah, very helpful for protecting against surges in uh, sensitive electronic equipment that we do not want to get damaged, like your um, PLC circuitry, your computers, data centers, that kind of thing. So, what is the importance of interpreting specification markings on circuit protection devices. So what is the importance of interpreting the specification markings on circuit protective devices? Cool. Some good answers. So it's to ensure the device is suitable for the application and meets the safety requirements and is correctly rated for the current voltage and tripping characteristics. So if you want something that's going to trip really fast, you choose an MCB. If it's okay for it to not trip at first, like if it's a motor, you choose a GM HRC fuse or a Type B for circuit breaker for motors. And yeah, or does it need to trip in AC or DC? Because you can get DC circuit breakers as well. You need to make sure it's not going to get destroyed with the fault current. So if the fault current's over 6 kA, you need to use a higher than 6 kA breaker. Cool. How does an overload relay differ from a standard circuit breaker? What's the main differences between an overload relay and a standard circuit breaker? Well, yeah, Daniel basically hit it on the head. So yeah, so an overload primarily protects motors by responding to prolonged overloads and preventing overheating because it takes time for the bimetal to heat up and then trip the circuit. Whereas circuit breakers provide broader protection, including overload and short circuit scenarios, and can isolate circuits quickly. Cool. So what regular maintenance should be performed on RCDs to ensure they function correctly? Yep, if it's a magnetic overload, it would be incident. Yeah, yeah. Push the test button. Yeah. You need to push the test button every 6 months. Unless it's a personal RCD, like the one you plug in, then you need to test it every time you use it. Or if it's a piece of service equipment, every time before it's rented out. Cool. So I will now everyone should be able to see the screen there. And now I will. Cool. Hopefully the majority of you can see that. If you can't, I am still recording the session. So it will be up on the YouTube channel after probably about an hour or two after this session ends. But I will talk through the whole PowerPoint as we go. Cool. So today we're talking about circuit discrimination and safety testing, unit standards 32614. Just before we get started, who can tell me what they think circuit discrimination means? Yeah, I did mean to say decommissioning. Sorry, guys. Yeah, so discrimination is something else. But yeah, some of you guys are guessing right about the discrimination. Cool. So that won't work. So the lesson objectives for today. So we're going to talk about the process for safe decommissioning, identifying test processes required for decommissioning and recommissioning of electrical equipment. We'll talk about the process for safe decommissioning and commissioning of electrical equipment, and we'll demonstrate safe decommissioning and recommissioning practices. So circuit decommissioning. So decommissioning refers to the safe removal of electrical fittings or equipment, ensuring that the exposed energy supply systems remain safe. It involves isolation, safety tagging, and securing isolation before any physical work begins. So when you come to do your block course, hopefully you guys have been given an email about that. I have been chasing them up about it. You will do a bit of lockout and tagout. Okay, so some of you still don't have emails yet. Okay, definitely, definitely something to follow up because it is coming up. It is in the calendar. Okay, I'll be sure to follow up on that. But we should do some decommissioning and recommissioning, and as well as lockout, tag out with you guys. Yeah, it may not be Connexus. It may be. Yeah, I know, Blake. I've been telling them that they need to let you guys know so they can you can sort out leave as well as any of you guys can figure out with your work. Cool. And then so circuit commissioning. So commissioning is the process of testing, livening, and functionally verifying electrical fittings or equipment before handing them over for use. It ensures that all components are safe, fully functional, and comply with relevant standards. So yeah, commissioning is all of the testing that you do before you deem a installation safe. So you check that you have the correct earthing, you check your insulation resistance, polarity. Only once you've done all your dead tests, do you then liven it up and then do your live testing. There are some tests that people do live that you can do while dead. They just prefer not to do it. Oh, so with circuit isolation, the two golden rules we must always follow. Test before touch. Always test that electrical wires are not live before they are touched. So you test everything before you touch it. So test everything before you work on it. And the way we test is we use the prove, test, prove meter. method. So prove that the meter works on a known supply, test it for isolation, prove that the meter still operates on a known supply to ensure that the meter didn't fail during the test, or as I like to put it, prove my meter works, test the circuit's dead, prove I didn't break my meter. And so we have the decommissioning process. So there is quite a bit of a process with it. So you got preparation and planning. So there'll be a long plan that you do before you do anything with the decommissioning process. So there's a lot of prep and planning to do, a lot of coordinating to do. So communicate and control the work area. So you'll have to communicate with the people using the area, and you'll have to set up controls in the work area to make sure that no one comes through it while you're decommissioning. So isolate all energy sources. So it may not just be electrical that you're dealing with. You may be dealing with a system that has pressurized air, plumbing, and gas. So you need to make sure all energy sources are live and before you do any work on it. So it's not limited to just electrical. So verify isolation, for us, it's prove, test, prove. And then for the rest of it, we just have to wait on the plumbers or the gas fitters or whoever to work, can communicate with us that their side has been isolated correctly. So secure isolation, so you lock out, tag out. So you will affix like in the photo, a appropriate lockout device to your isolation point. This could be a padlock, it could be a padlock and hasp. So a hasp is, I'm sure some of you guys will have seen it. You've got basically it's a hook that hooks onto the isolation point, but it's got 6 to 10 holes for different padlocks. And so what that means is you can have one hasp, but you can have 5 different people locking out that one hasp, so that all 5 people who are working on the equipment have to say, yes, it's safe to turn on before you do it. Well, make the equipment safe. So you need to discharge any residual energy. So if you have any capacitors inside the system or stored water, gas, or pressurized air, they need to be released and dissipated. Check for any hidden hazards. So inspect the equipment for any more residual energy or hidden dangers before you do any work. And then implement mechanical safety measures. So security parts that could move or create a hazard during maintenance. So chocks, supports, and restraints. You perform the maintenance of the repairs, so you ensure all of the correct PPE and tools and maintain safety standards throughout the maintenance process. Then you can prepare for recommissioning if applicable. So remove the tools and equipment. So ensure all tools and safety devices are removed from the work area. Double check the equipment is ready to be energized safely. Inform everyone that recommissioning is about to begin. Process for discharging a capacitor is you take an appropriately sized resistor and short out the terminals of the capacitor. One way of doing it is you get a nice big thick iron rod, grab a glove, and then take the iron rod in your gloved hand and put it across the capacitor terminals. That is one method. It's not the only method, but do not ever try and use your pliers. There is a high chance you could damage your pliers doing it that way. Also record and document the process. So document the decommissioning process, including the isolation points you used, the safety measures put in place, and the maintenance activities you did. Ensure all records meet the relevant safety and regulatory requirements, as well as the requirements of the site or business that you're working in. And then issue any certificates like safety, ESCs, COCs, and ROIs if required. And then debrief and review. So analyze the decommissioning process and identify any areas for improvement. Provide feedback. Engage with the team to discuss lessons learned and reinforce best practices. Revise safety protocols or decommissioning plans based on the review findings. Cool. Cool. So securing isolation. So after de-energizing equipment and obtaining permission to de-energize, isolate to prevent reactivation. So since removing the conductor isn't always possible, deactivation occurs at the circuit breaker or isolation point. So a lockout device is anything requiring a tool or key must be applied, and a lockout tag must indicate it remains de-energized until authorized reactivation. The locking a circuit out can be done at the circuit protection or isolation point near the equipment. For multiple workers, the hasp, which you can see in the photo on the left there, allows several locks, ensuring the isolator is only released when all locks are removed, preventing premature re-energization. A danger tag must accompany the lockout to indicate ongoing work and prevent accidental activation. So this tag has to have So it must be clear, durable, and legible, stating the circuit breaker or isolator must not be operated. It should include the name and contact detail of the person who applied it and the expected removal time. You can't just stick the lockout on it. So like a lockout device on a circuit breaker and then put a cable tie on it. That is not an effective means of isolation. Cool. So an out of service tag, some yellow and black, indicates that equipment is unserviceable and unsafe to use. Unlike a danger tag, it can remain for an extended period, even when no work is being done. Cool. So common mistakes in decommissioning. So failing to verify de-energization, not testing circuits before work, or using proper voltage detectors. Ignoring lockout tagout procedures, so forgetting lockout tagout devices or removing tags too soon. Incorrect circuit identification, so shutting off the wrong breaker, fuse, or failing to label decommissioned circuits. Disconnecting live circuits, removing wires when energized or not isolating power sources. And improper PPE, so not wearing insulated gloves, safety glasses, or arc flash protection near high voltage panels. Cool. And then we have the recommissioning process. Cool. So again, prep and planning. So it may have been a couple days since the area was disconnected or decommissioned. So we need to do preparation and planning. So we need to review documentation to ensure all the maintenance, repair, or modification work has been completed satisfactorily. Remove maintenance logs, review maintenance logs, safety checklists, and any changes made to the equipment. Develop a recommissioning plan, which should have already been done in advance. So establish a clear sequence of steps to safely reintroduce energy sources to the equipment. So what sources of energy need to be reconnected first? Is it the gas that needs to be connected first? Is it the water? Is it the power? Is the circuit protection devices or any relays going to trip out and cause the machine to not be able to operate if it doesn't have gas or water? Conduct a risk assessment, so identify potential hazards associated with re-energizing an equipment and develop control measures to mitigate it. Our pump's going to start to activate, our bellows going to open, our risers all of a sudden going to be lifting up. And then verify compliance. So check that all safety and regulatory requirements and factory requirements are met, including compliance with ASNZS standards and any site-specific protocols. So inspect the equipment and work area. So perform a detailed inspection of the equipment to ensure it's intact, clean, and free of debris. Verify all mechanical parts are secure and that guards, screens, and covers are correctly installed. That's a big one, especially if there's spinning parts, like any motors, fans, or if it's a high-powered milling machine. You want to make sure all guards are in place so that nothing can accidentally come in contact with the spinning or crushing or any type of blade. Ensure wiring is correctly terminated, connectors are secure, and no exposed conductors are present. And make sure all electrical connections are safely secured inside a terminal box and not open to the air or potential contaminants. Clear the work area of any tools, materials, or temporary safety devices during maintenance. Cool. So verify your safety measures. So ensure all lockout devices and tags are still in place and clearly visible. Double check that all energy sources remain isolated and that there's no residual or stored energy. Make sure all personnel involved in the recommissioning process have appropriate PPE and that it is in good condition. Cool. Test before re-energizing. So conduct your electrical test. So confirm do your earth continuity test. So you confirm a safe path to earth for exposed conductive parts. Your insulation resistance or IR test. So check the integrity of insulation to prevent short circuits. Polarity test, ensure that active, neutral, and earth conductors are correctly connected. Mechanical and functional tests. So operate controls manually, test the control devices, e.g. emergency stop buttons and manual switches to verify functionality. So just a push test and then test moving parts, test that mechanical components move freely and safely without obstruction or any rubbing or undue friction. Then you can remove your lockout tagout devices. So authorized personnel only, ensure only the person who applied the lockout tagout devices removes them following site protocols. Remove locks and tags to safely remove all lockout devices and warning tags. Communicate status change, notify all personnel that the equipment is about to be re-energized and confirm the work area is clear. So sometimes you might not be the only one working on the machine from your company. So oftentimes, for example, my last company, we had a bunch of lockouts, but all of the keys were kept with the site manager. So more than often, I was the one applying lockout tags to certain equipment because we were livening switchboards, but we needed to make sure they remained off because the sub circuits were not safe to be turned on yet. So we would isolate the main switch with a lockout tag out. So I would go lock it out, tag it out. I would say the company, and I would put my contact details as well as my manager's contact details. And then most of the time, I was also the one who removed the lockout. But there are times where you won't. And if it's a shift work situation, what will happen is the person who applied the lockout will go with the person who is replacing him. The original person will take their lockout tag off, and the person replacing him will put their lockout tag out on. Yeah, safe remove. So notify all personnel that the equipment is about to re-energize and confirm the work area is clear. Cool, and then we can re-energize the equipment. So sequential re-energization. So we'll gradually restore power to the equipment, beginning with low-risk energy sources, so control circuits, and progressing to higher-risk sources, so mains power, hydraulics, pneumatics. So we'll observe the equipment closely during the initial energization phase, looking for any signs of malfunction or instability, and then we'll verify the control functionality. So we'll test emergency stops, safety interlocks, and control panels to ensure all systems respond as expected. So you'll also do the same when you're turning on the motor control circuits. You'll test that if you put it in forwards, you can't then put it in reverse at the same time. And then if you put it in reverse, you can't put it into start at the same time. If you've got star delta starters, which is something you guys will learn about later on, where it energizes the circuit in one configuration and then after 10, 20 seconds changes over. We need to make sure that we're starting the process, waiting for the correct timing, and then watching it click over and making sure the correct contactors don't the correct contact is engaged at the right time. Then we'll perform functional testing. So we'll operate the equipment under supervision, run the equipment through its full operational range in a controlled environment. We'll test the safety system. So we'll verify that all safety features, including emergency stops, interlocks, and alarms, are functioning correctly. So we'll simulate operational scenarios. So we'll introduce safe test loads or conditions that mimic normal operation to validate performance and safety. We will confirm operational readiness. So we'll evaluate equipment performance against expected parameters such as speed, load, capacity, and operational efficiency. We'll record all the test outcomes, including safety tests, functional tests, and performance data, ensuring compliance with standards and regulation. We'll conduct a visual inspection, so looking for any signs of wear, damage, or potential safety issues since we turned the machine on. We'll then communicate the recommissioning status, so we'll notify the stakeholders, so the relevant personnel, so operators, supervisors, safety officers, and the equipment is fully recommissioned and ready for use. We'll update signage and documentation, so replace the out of service signs with appropriate status indicators, and update maintenance records and logbooks. So okay, so this video may or may not play. Doesn't matter too much if you can't hear it. Yeah, so if you're the person who puts the tag on, you should the lockout on. You should always keep the key with you. Never just give it to someone else. It's your responsibility to make sure you isolate and then release that equipment properly. Don't just give it to your mate because it's easier. Especially if you're still working on the machine. Health and safety man is not impressed. I don't know. I've had some health and safety guys give me compliments, even shout me lunch. And so as we saw in the animation, he gave his key to his friend rather than finishing the work and going and removing his lockout himself. Yeah. So here you go. They'd locked it off electrically, but they hadn't removed all of the stored energy, so there was still pressurized air or gas in the line. Yeah, compressors turned off. They lock out the machine. Then they go and bleed the system. In this case, it's water. They drain all the water out of the system. Oh, sorry. The water that collected in the bottom of the compressor also comes out. If any of you have drained an air compressor before, you know a lot of water condenses inside the machine, so you've got to drain it regularly to make sure that gets gotten rid of. So now it's safe to work on the equipment because the pressurized air is gone. Locked it off, tagged it off, working on the machine. But he's only locked out part of the machine. He hasn't locked out the entire machine. So you need to make sure you lock out any upstream services as well. Battery locked out the wrong piece of machinery. Yeah, there you go. He's locking out 2 and 3. Yep, locked out the wrong piece of machinery there. There he's locked out both, and he's ensured that they're not both not working anymore. Oh, so I will share. Cool. So that was a little video about lockout, tag out. So you always need to make sure you're locking out the correct piece of equipment and doing all those things. So why do we decommission machinery? Yeah. So the main reasons we decommission the machinery is because we need it to be safe for us to work on it, or if it's no longer safe or working, it needs to be removed from service so it doesn't accidentally become live. And we go through the decommissioning process to make sure we do it properly. Um, One example, if we were decommissioning one switchboard inside of the Wakefield Hospital facility and then recommissioning a new one. Because it was feeding certain areas of the hospital, we had to wait until the weekend when they had less patients and they could move them to areas we wouldn't be affecting. So then we had to decommission the board, just double check we hadn't accidentally turned off anything that wasn't supposed to be turned off, and then recommission it afterwards. This was at stage one, Andy, if you're wondering, not stage two. Cool. So what tests must be carried out to ensure the machine is safe to work on? So, well, what are some of the tests we need to perform? So yeah, for our part, when we're doing work on machinery, we need to use the test before touch and prove test prove. So test the circuit before we work on it, prove our meter works, test the circuit is isolated, prove our meter still works. So we prove it on a known live source, we test the circuit that's supposed to be dead, and then we prove it our meter's still working on that same live source. Well, so what are some non-electrical sources we must be wary of when working on complex machinery? Yeah, basically, it usually has to do with hydraulic or mechanical. So your compressed air, your hot water, your pressurized water, your gas, chemicals. One rather specific one is if you're in a flour mill, flour is very highly combustible. And if it gets aerated and there's a spark, it will cause a massive big bang. If you guys ever want to watch a particularly entertaining video, look up Mythbusters coffee creamer cannon. They basically stuck a road flare inside a giant vat of coffee creamer and then use pressurized air to send it up into the air and create a giant fireball. Cool. So, what tests must we do before recommissioning the machinery? Um, Basically all of the same tests we do before we when we do the decommission, we do again when we recommission. Um, so why is the paperwork important? Yeah, so mostly we do paperwork for a paper trail, just to confirm we've done things. So when we test an installation that we've done, we make sure we test every circuit. We test pretty much every PowerPoint we can. We test every exposed metal part that's bonded because we want to make sure everything is, yep, test everything. We want to make sure everything is tested properly. And then we need the document to say, hey, we tested everything. When we finished the job, everything was working. And so if something's wrong now, someone else did something dumb. It's come up a few times because done jobs for companies and then they have an issue couple years later, and then it's like, well, no, you've had work since then. We know because we've got the photos, test results, plans, documents, everything, and this doesn't look like the way we left it. You've had someone else in here. You'd think it wouldn't be as crucial in domestic, but because some people who own houses think they can do their own electrical, we need to make sure we document everything as well. So take photos, do test results, take photos while you're doing your test results. I know some guys who it's really funny, they wear cameras on their foreheads while they're doing their testing to make sure they have video evidence. It's only a couple, but they're really paranoid about anything going wrong on their jobs, which they shouldn't because they're great Sparkies. Cool. So, guys, I will just quickly stop recording there.